Topic 3-2, dividing a polynomial by a monomial. This can be referenced in our Holt textbook, Chapter 8, Section 2 on page 531. This topic we're dealing with finding, first off, what would be divided by both. And so it's showing in this first one that a 9 and a 12 have a greatest common factor of 3, so we could divide a 3 through this whole, both of these, and it would end up being, with a division, 9y divided by 3 and the 12 divided by 3. So even though it's showing to be divided by the whole thing, you can break it up into each term. So once you've divided 9x divided by 3, 9 divided by 3 is 3, 12 divided by 3 is 4. On this one, both of your terms, your coefficients in front of your variables, can be, if divided by 4, can be broken up into two terms, taking the 4, dividing it underneath each one. 16 divided by 4 is 4. There's nothing common with an a, so it stays. 20 divided by 4 is 5, and b has nothing to cancel out, so it also stays. So that's dividing polynomials by monomials. So look at this one. It's a little bit more extensive, but in this, if you divide each of these terms by a 9, you can also factor out an r, because there's an r in every term. So, and also dividing out a negative just happens, if this one happened to be a negative, ends up changing everything, because you've got minus this being negative, minus this being negative. So be real careful what happens with your integers. This stays negative. This actually is going to become positive because you have a negative 18 and a negative 9. This minus sign takes on the value of the 18. This negative 36 is minus 36 in the problem, but takes on the value of that negative. And so that's why you have these two positives once you've done the division. So carefully dividing out each one of these, you've got to make sure you follow the integer rules. Two negatives make a positive. Where's that one? It's right there. And then this one's a positive and a negative, so that's actually going to stay a minus sign. Plus a negative is the same thing as a minus sign. So take a minute and make sure you've copied down notes for how to divide, especially the number 3 and 4. What is the range of the following function? This is talking about domain and range. So you're dealing with looking at values of your x. Domain is your x value. Range is your y value. A little trick that Mrs. Horner taught us was Dr. XY. So if you kind of can think of that, the D goes with the X, the R goes with the Y. Another way to remember that is D comes before R in an alphabet, if you're thinking about the alphabet, and X comes before Y in the alphabet. So not forgetting which goes with domain and which values go with your range. So what they're asking you here is to put then a negative 2 for your x, put in a 1 for your x, and put in a negative 3 for your x. These are my domain values, and remembering that f of x means the same thing as y equals. Kind of squeeze a little y up there. So all they did was they put in a negative 2 where they saw this x. They put in a 1 for that x, and they put in a negative 3 for that x. Solving it for each one of those gives you these values, therefore the range in brackets. Make sure you put it in a bracket form. For those given domains would be 11, negative 1, and 15. When graphing domain and range functions, look at these. You're actually given the domain, we have to look for the domain, and those are your x values, and the range being your y values. You're giving the values of where these dots were. On this one, because this one's a solid line, it's kind of hard to see on mine, but that's supposed to be an open circle. So I'm going to put open. That's an open circle. And then this is a closed circle. You know, this is showing the range to go from here to here and the domain go here to here. Interestingly enough, these brackets get a little confusing. What I try to teach kids to do is to put a box around all the way across your X's and your Y's. Oops, went too far with that yellow line. If you'll, what's called a frame, if you just kind of put a frame around it. So by stopping at -1 on my Y, and it also went up to a 6, but has an open circle. So that's why with an open circle, you have to have just an inequality sign here and here. Because this is a closed circle, my X value is what is that? -6, and it goes all the way to a 5, but it's actually open. I have a whole worksheet on this. This is definitely something that will be tested. So if you still need some help with this one, come see me and we can kind of go through a few more examples framing out each of the lines that are asked to find the domain and range. Okay, look at number 8. On this one, this is a calculator trick. We're going to find this equation by just adding these numbers into your stat button. So using a calculator when you have a problem like this. The owner of a bookstore recorded the following information last week: the number of customers and the amount of sale. If you put these in stat, you're going to come up with this calculation of a linear regression. If you haven't done this before, make sure you go through this a couple of times. If you don't get it, or definitely come ask me and I can show you. But with this, there's your stat button right here. So you're going to push the stat. The edited button is already highlighted. So what you want to do is make sure your L1 is cleared out. In fact, make sure you understand that these values go in the L1 and the second values, which are always your Y, go in your L2. And, well, not always, but this is your X values, your C, and your S values are ended up being your Y. In other words, in your equation, Y equals something X. A linear regression is what we're going to be looking for. So you put in the values: 9, enter; 14, enter. You do have to hit enter each time. Enter. 24, enter. I think you don't have to actually put all of them. Let's just see if it'll come up with this close to this value with just these. 66, enter. 86, enter. 106, 126. What you do have to have is a value on both sides, however many values I have in my L1 column, I have to have in my L2 column. L1 being your X values, L2 being your Y values. Then you hit, once you've loaded up your calculator with the statistics, you hit stat again. This time you're wanting to move over to this word calculate using the arrow key, and then find where it says on number 4, which you might want to note here, that this is number 4. You're hitting the number 4 button. You do want to hit it twice. If you only hit it once, you're not going to get the equation. But if you hit it twice, you see that Y equals, you plug in your A, which is like your M. In the calculator they use an A instead of an M. So 4 became my slope. X plus 30 is my Y-intercept, which is B. Very valuable, important. Don't forget, you know, put on here no. You want to know how to do this. Lots of standardized questions that you can actually get equations by just using this stat button. Okay, so let's look at this one. Here's another one we can use our stat button for. A science experiment involved hanging objects of various weights on a spring. The graph shows how much a spring stretched with the various objects attached. So if you plot these points, and notice these are approximations. I put little stars by the ones that aren't quite on a point, but a little bit above. So you do the same. Look at these plotted points. Enter these values in your L1, these values in your L2, and it's going to be an approximation. The actual buttons you're going to hit again is Stat. You're going to move it over to Edit and enter your points. You'll hit Stat again. Actually, you don't have to move over for Edit. It's the first one. But you do slide over for Calculate. And always look for something that's aligned with a number 4, linear regression, hitting it twice. And this is the equation that you should end up with. Okay, the last thing on this says, based on this information, what's the best prediction of the length of a spring with 10 ounces? Well, if X represented our ounces, because in ounces, this is my X-axis, this is the Y-axis. So even though they've used a word problem here, we're still looking at a graph where you have your X values and your Y values. So round this to the nearest whole number, and you'll have your answer as 10. So 10, the best prediction of the length would be that it would have to be 10 inches because the spring is in inches. Anyway, that is 3-2.